Okay, before we get started, it's time to do the news. Do you like video games? If so, Bethesda just released this new game on September 6th of this year called Starfield. It looks really, really cool. Okay, so there's this article about the best melee weapons in Starfield. You have things like the Ripshank, the combat knife, and, the Osmium dagger. It's valued at 2,395 credits, has a mass of 2.7, whatever that is, and deals 28 points of physical damage with each strike. It is small, precise, and perfect to quickly pull out and strike at an enemy that has gotten too close during a gunfight. Most significant appeal of the dagger, however, is its rare exterminator effect. This effect gives your physical attacks a 30% damage boost against alien targets. That sounds really, really awesome. Okay, now this isn't product placement, obviously. I'm not trying to promote the game. Um, it looks like I am. I don't make any money off these videos, so I'm not profiting off of this in any way. But I just think it's really, really cool that Osmium's getting recognition in big video games like this that look this awesome. In other news, it is time to do the Osmium spot price for today. Today's spot price has been calculated based on all the different sources on the internet and all the compilations of data that I've gotten from them. And based on that, I can confidently say today's spot price is the letter Eth from the Icelandic alphabet. Okay, let's get going with this. Alright, where should I start? I'll start with iron. Iron is absolutely awful. It is, of the transition metals, probably the least corrosion resistant. It reacts with hydrochloric, hydrobromic, hydrofluoric, probably, sulfuric, nitric. Pretty much reacts with a lot of acids. Reacts with salt water. Reacts with moist air. It rusts. It crumbles to dust. It is absolutely the worst. It deserves to go into F tier. With that going in F tier, that brings us to zinc. Personally, I think zinc is more reactive than iron. Strangely enough, it is more corrosion resistant. It reacts with acids and bases alike. Which acids? Probably all of them. It gets a solid E tier because zinc is actually used to coat iron to stop it from rusting. To basically act as a buffer between it and the iron. Okay, what should I do next? Manganese, why not? Manganese is a pretty reactive metal. It doesn't quite rust like iron, but it does react with air quite easily, and it does react with acids, and it has a pretty diverse chemistry to it as well. This can go into E tier because I don't know where else to put it. Okay, titanium. Titanium has great corrosion resistance. I will just say though about titanium that it will react with sulfuric acid of high concentration, and it will react with probably any concentration of hydrofluoric acid. When it comes to hydrofluoric acid, titanium is like a moth to a flame, literally. However, its resistance to chlorine is extremely good. It can go into B tier. Cobalt. Let's do cobalt next. Cobalt is probably better than iron. It doesn't rust. It doesn't tarnish or react with air. I don't believe it reacts with water either. Zinc actually does. Zinc will tarnish if it's submerged underwater for long periods. Personal experience. However, cobalt is highly vulnerable to halogens such as chlorine, iodine, bromine, fluorine most likely, probably, definitely. And it reacts in dilute acids. I don't know the extent of how many acids it reacts in, or if it reacts with all the weak acids as well, but I think it deserves to go into D tier simply because it won't react with water. Niobium. Niobium, like titanium, has great corrosion resistance. Um, it doesn't really respond much to nitric acid. Uh, it will dissolve in hot concentrated sulfuric acid. It does get attacked by that, personal experience. And it is also dissolved in a mixture of hydrofluoric and nitric acid. Um, Hydrofluoric alone will also dissolve this metal. It can go into B tier. Also, it has super great resistance against the halogens. Copper. Copper is a pretty good metal, I think. Um, it will tarnish in air. It will oxidize. But it is resistant against hydrochloric acid, and you basically need an oxidizing component in an acid in order to dissolve this metal. It can go into D tier because I think it's earned it. Even though it's definitely a bit more resistant than cobalt. Yttrium. Yttrium is one of the rare earth metals. It reacts with acids. How many acids? Probably all of them. It also reacts very slowly with water at room temperature. It can go into E tier. Palladium. Palladium is a very, very good corrosion resistant metal. Not quite as good as gold. It is vulnerable somewhat to the halogens and definitely in nascent halogens in solution, very much so. It's also vulnerable to hot concentrated sulfuric acid as well as nitric acid at room temperature. So it can go into B tier. Zirconium. Zirconium is a pretty corrosion resistant metal as well. Um, it's a little bit more vulnerable to sulfuric acid than titanium is. And my assumption is that it's also more vulnerable to hydrofluoric acid as well. I don't know that for a fact, it's just what I'm assuming. For right now, it can go into C tier. And actually, as a matter of fact, put hafnium there because wherever zirconium goes, hafnium goes because they're so chemically similar. Okay, vanadium. Vanadium is a very corrosion resistant metal. It's resistant against acids. Hydrochloric acid does nothing to it. Nascent chlorine in hydrochloric acid does absolutely nothing to it. It will tarnish from chlorine gas though, and it will tarnish slightly in iodine vapor. And it will get somewhat either tarnished or etched by hot concentrated sulfuric acid. It can go into C tier. Oh, I should also mention about vanadium. It's very, very vulnerable to hydrogen peroxide. It dissolves very, very rapidly in hydrogen peroxide. Very readily. Let's see. Silver. Silver's corrosion resistance is only as good as its ability to tarnish, which is it is very able to tarnish. It is very easy to tarnish silver, so it can go into C tier, and just be glad I'm not bumping its ass down to D tier because its water insoluble compounds are the only thing keeping it in C tier right now, as far as I'm concerned. Nickel. Nickel actually is surprisingly corrosion resistant. You wouldn't believe how corrosion resistant it actually is. That being said, however, it doesn't hold up that well under super corrosive conditions. Sulfuric acid will dissolve it. Nascent chlorine in HCl will dissolve it, and nitric acid will also dissolve it. But it is difficult to tarnish. Even chlorine gas can barely tarnish it, and iodine vapor can barely tarnish it. So it can go into D tier. Cadmium. Let's just stick cadmium in E tier. It's actually it's pretty high E tier actually. It's pretty similar to zinc except more corrosion resistant, but it reacts with all the same stuff, just not as rapidly. Scandium. Scandium is one of those expensive metals, but it is not a noble metal. It reacts with acids of all kinds, and it also reacts with water very slowly at room temperature. It can go into E tier. Tungsten. Tungsten is well, I'm not going to say extremely. It is a very, very, very corrosion resistant metal. Um, it's resistant against hot concentrated sulfuric acid, and very few things can withstand that. Um, it will, however, dissolve in hot nitric acid, hot concentrated nitric acid, and it will also dissolve in a mixture of hydrofluoric and nitric acid at room temperature. But it is resistant to aqua regia at room temperature, so it can go into A tier. Chromium. Chromium is going to be a very difficult one for me to place because it is surprisingly resistant. It is very, very resistant against the halogens. It has to be in a hot mixture of nascent chlorine in HCl in order for it to even tarnish. And that tarnish is not thick, let me tell you. Hot concentrated sulfuric acid will form a thick passivation layer on it. That's about it. However, dilute acids will dissolve it. God, this is tough. C tier. Put it in C tier. And that's a high C tier too, like better than silver C tier. And probably better than hafnium and zirconium C tier as well. Maybe put it, yeah, there we go. Yeah, that's probably good. Ooh, technetium. Technetium can go into D tier because it does not dissolve in hydrochloric acid, but dissolves in, other acids that aren't hydrochloric. And it will also tarnish in air as well. So I think it's earned its place in D tier. Rhenium. Rhenium is a very, 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 very corrosion resistant metal. It's resistant against both aqua regia and a mixture of hydrofluoric and nitric acid, both at room temperature. It's resistant against hot concentrated sulfuric acid. I don't remember what Historical Marine 45 told me about his test with 70% hydrofluoric acid, if it etched it or not, but either way, I think it has earned a really high A tier. And it brings me to tantalum. Tantalum is also a very, 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 very corrosion resistant metal. It's resistant against nitric acid at room temperature. Hot concentrated sulfuric acid probably only etches it a little bit. And it's also extremely resistant to chlorine, including nascent chlorine. However, hydrofluoric acid will attack it, and it will dissolve at room temperature in a mixture of hydrofluoric and nitric acid quite badly, I might add. So it can go into A tier because it's also resistant against aqua regia. Ruthenium. Ruthenium is a very, and not even very, it is an extremely corrosion resistant metal. However, it does have some flaws, like several of the other noble metals do. Bleach is one. Another surprising one is before I bleached my ruthenium bead, I actually managed to permanently damage it with a mixture of aqueous sodium hydroxide and potassium permanganate. I mixed those two things together. It did not, yeah, the surface was permanently damaged from that. I tested osmium in that same mixture, and osmium was fine. So yeah, it can go into S tier because I don't think Historical Marine 45 and I have found an acid that it reacts with, like, at all. Yeah, that's a solid S tier. Mercury. This one's a tough one to place for me. Let's put it into D tier because it will oxidize if left in air for long enough. I've seen it. My own sample in my element collection has oxidized. It's got powdery black shit in it. Quite a lot of it, actually. Um, and it will react with oxidizing acids as well. Gold. Gold is very, very, very corrosion resistant. Um, Hot concentrated sulfuric acid won't do shit to it unless some of it is exposed to air. Then it will tarnish a little bit. Hot nitric won't do anything to it. It will, however, dissolve in hot aqua regia, and I have reason to believe that a mixture of hydrofluoric and nitric acid will also dissolve it at room temperature. So it can go solidly into A tier. Rhodium. Rhodium is a very, very corrosion resistant metal. Yeah, it's pretty resistant against aqua regia even when it's hot. I think molten potassium bisulfate will dissolve it. I forget which chemical it was, but rhodium is very difficult to dissolve, so it can go into S tier because it is extremely corrosion resistant, like really extremely corrosion resistant. Molybdenum. Molybdenum, I think this can go into... Oh, geez. Where does molybdenum go? Come on, think. Where does molybdenum go? I think molybdenum can go into D tier. I think it's earned that spot in D tier. I think. Or you know what? No, put it in the C tier. It is vulnerable to hydrogen peroxide, even at only 3%, but it is invulnerable to hydrochloric acid, just not to chlorine or nascent chlorine. Iridium. Iridium is so next level corrosion resistant. I think it has earned a really like outside of S tier. Like that is how next level corrosion resistant it is. Lutetium, this can go into E tier. It is a rare earth metal. It reacts with acids, and it also reacts very slowly with water at room temperature. Platinum, S tier, easily. And last but not least, our favorite osmium. Woo! Osmium is resistant against aqua regia at room temperature. It is also resistant against mixture of hydrofluoric and nitric acids at room temperature. It is considerably more resistant to bleach than ruthenium is, and it is not as easily attacked by oxidizing alkaline mixtures as ruthenium is. Easy S tier. It is extremely corrosion resistant. And I think that's it. I think that's all of them. All ranked. There we go.